Perfect. Got our recording going, and you guys are just about ready to see my notes page that I've got up. Yesterday, I believe I left off with that we were discussing absolute value, right? We were discussing the notion of absolute value. And forgive me, I don't recall if I gave you did I give you some homework to work on? Not yet. Okay, good. Thank you guys for helping me. I've got it feels like I teach 4 different classes, and so sometimes I get forget which one is which with you guys. That's okay. Awesome. All right, so we're set up online. We're set up with my screen here. What I want to talk about today is the notion of a set of numbers. Up at the top of the screen, I've got a set of numbers known as the integers. Okay. And Quentin, what letter do you see that we use to represent that set in blue there? Yeah, it's kind of a funny looking Z though, isn't it? It's what I just refer to as a scripted Z. It's got just like a little double bar down in the middle there. Kind of messed up on the top. A little double bar down the middle. You know, sets of numbers, we use symbols to represent them, and it's helpful to understand, you know, some of the different characteristics of different sets of numbers. So like we might have talked about the set of natural numbers before, 1, 2, 3, 4, so on and so forth. We've actually probably also talked about the set of integers before, where it's positive and negative counting numbers. There's a set of rational numbers. There's a set of real numbers. There's a set of complex numbers. So there's all these sets of numbers. So today we're going to talk about integers because in discussing things with my buddies in the math department, we oftentimes bemoan the fact that students that struggle in algebra, okay, which hopefully wouldn't be you guys, but students that struggle in algebra typically do so because they have a hard time doing operations with the integers. Now, what I mean by that is adding, subtracting, multiplying, and dividing positive and negative numbers. That's what they struggle with. And I know that sounds crazy, but when we look at guys that have a difficulty in their 9th grade year, in their 8th grade year, or whatever, it oftentimes stems from that basic, gap in their background. And so when we look at in section 1.2, when we look at integers, one of the goals that I have for us is to put into play the order of operations we talked about last section, and to also just learn about a few of the pitfalls that we sometimes see. Okay, and what I mean by pitfalls is areas where we might see common mistakes that get made in class. The first example, as a matter of fact, is one of those pitfalls where I've got what might seem like just an innocent enough example of 2 things that are very similar. So let's break this example down. Let's look at it here. We got -2 in parentheses raised to the 4th power. Okay, so Charlie, what does it mean to raise something to the 4th power? We multiply it by itself 4 times over. Very good. Exponents are shortcuts for repeated multiplication. We know that. That's pretty standard. But what are we exponentiating here? Like, what are we raising, Colin, to the 4th power in this first little example? Kozlowski, can you unmute and answer? No? Okay, Nate, how about you? What is it that we're raising to the 4th power? What is it that, as Charlie said, I need to multiply by itself 4 times over? Brownlee?
-2.
Yeah, so I'm going to go -2 times itself 4 times over. That's not rocket science, is it? And yet, here it's important to understand how many -2's are there? There's an even number of negatives. So, Luke, the result would be what, as far as its sign is concerned? It'd be what? No, it's sign, positive or negative? Positive, good. Since there's an even number of factors, it's going to be positive. And it's actually going to be positive what? What's 2 times 2 times 2 times 2? 16, good. Thank you for raising your hand, Quentin. 16. So when we look at -2 times -2, obviously that's 4, and then times -2 is -8, times -2 again would be positive 16. So what's the difference down here with the second little piece? Okay, in this case there are no what? There's no parentheses, right? There's no parentheses, good. So I'll ask the question, Joe, what's being exponentiated here? What's being raised to the 4th power? Is it really? So the question, if you didn't hear that at home, if you didn't hear that here in class, he said, I said, what's being raised to the 4th power? And he said -2. It's really not. Okay, and it goes back to order of operations. Okay, what comes first in order of ops? Parentheses comes first. All right, there aren't even any daggum parentheses on this one, so we don't have to worry about that. What comes next? Exponents comes next. Exponents trump multiplication in terms of priority. So look at, you say, well, wait a minute, what are you talking about multiplication? Look at what we could redo. We could say this is the same thing as -1 times 2 to the 4th, okay? Because the negative is not being exponentiated. It's not being raised to the 4th power because there weren't what? There weren't parentheses. So that's a big, fat, hairy difference, isn't it? Okay? Because now, okay, so what's being exponentiated is the 2. So this is like saying -1 times 2 times 2 times 2 times 2, which is -16. So in your notes, I want you to write down that parentheses matter. Okay, parentheses matter. Makes a big difference as to whether or not there are parentheses when we're following little examples like this. All right, so questions on example 1. Anything you want to ask about? Does my voice sound weird coming out of this little speaker, you guys in class? Kinda. Somebody yesterday said, you sound like Darth Vader. Okay. Could sound like worse things, I suppose. At least I don't have to yell right now. I'm talking in my nice, low, sultry, calm voice. I'm not having to yell all day long so that you guys can hear me. And you guys at home, obviously, I hope y'all hear me just normal like as usual. Okay? Hey, let's look at a second example that's similar to this. Again, all we're doing is playing around with integers, positive, negative counting numbers, right? Okay. So in this case, James, what's being exponentiated on this first one? What's being raised to the 3rd power? -3. Very good. Okay. So -3 is being raised to the 1st power here. So that means to the 3rd power, excuse me. So that's -3, -3, -3. Does anybody have that one memorized? What's -3 cubed? Quentin?
26.
-27. Good. And then now we're kind of picking up on the difference, right? Down here, this would be not -3 times -3 times -3, but negative, and then 3 times 3 times 3. If you want to put the 1 there, you're more than welcome to. Okay? But the coefficient, the negative sign, doesn't get applied until after we do the exponent. Okay? Jot that down if you want to. The negative doesn't get applied until after we do the exponent. Now you might look and you might say, well, wait a minute, there was a difference in the first two. And then here you say, well, there's not a difference. There's no difference. So the question is, why? Why is there no difference? All right, Quentin? All right, good. I'll say that out loud so if you didn't hear that. There's an even number on the first one, as far as the exponents go, and there's an odd number on the second one. So we want to keep an eye out for what type of exponent we're actually using. Are there parentheses? And then just simply, do the arithmetic. Now here's a little recommendation for you. I'm going to give you a little bit of homework tonight. Okay? Now this is going to be a strange homework assignment, Tiago. You ready for it? Okay, I want y'all to go play a video game, a little computer game. And you probably have played this before. Or maybe you have, I don't know. But it's called 2048. Anybody played 2048 before? Love that game. That game is awesome. Well, it's kind of old, so I hadn't played it in a long time. But it's a good game because it's kind of addictive. It's a little time filler, if you will. But also, I'll tell you, it helps you learn your powers of 2. It helps you memorize these powers of 2. So like obviously 2, and then 4, and then 8, and 16, and 32, and 64, 128, 256, 512. What comes after 512? 1024. And then after 1024? 2048. All right, so recognizing those numbers, like I'd be able to spout them off pretty quickly, right, is a pretty good little skill to build up. And you build it up by practicing and playing that little 2048 game. And it's kind of fun, and you can challenge yourself. It's it's innocent enough endeavor. But my encouragement to you guys is learn your powers of 2. At least have memorized the first 5. Okay, so like 2, 4, 8, 16, 32. So like if I said, hey, what's 2 to the 5th, you'll know automatically that's 32. Okay? And then also I'd learned my powers of 3 up to 3 to the 4th. What is 3 to the 4th? Call it out, Oxley. 81. Good. Okay? So like having these memorized, it's not like I'm going to roll up in here and say, hey, you guys got a test tomorrow. I'm going to have a memorization test. on what these, no, that's not what I'm talking about. But they're going to come up so frequently in class. They're going to come up so often that you're going to want to save a little bit of time by having them what? Having them memorized. Same thing goes with our perfect squares, right? You guys have your perfect squares memorized? How far do we go? Let's see how far we can go. 1 squared. Come on, everybody participate. 2 squared. Louder. 3, 4. All right, keep going. 25, 36. Why aren't you guys at home talking? 49, 64, 81, 100. All right, stop. My 3rd grader last year learned those. Okay, so if you don't know those, shame on you. Okay, we ought to have those memorized. Let's keep going. 11 squared. 121. 12 squared. 144. All right, stop. Okay, so most 4th, 5th graders have learned 12 squared. Okay, I've learned up to the 12 squared. What's 13 squared? 169. Be loud, be proud. 169. What's 14 squared?
96.
196. Okay, what's 15 squared? Oh, that one's easy. Come on. We know it's going to end in a 5. 225. Okay. And what's 16 squared? We said that one a minute ago. It's on the 2048 game. 256. 256. I'll pause right there and tell you a real quick story. When I was in college, and back in my day, sonny, when I went to college, it was in the year 2002. Okay. 2002, I started college. And I had to have a little USB flash drive, a little jump drive. You know what I'm talking about? A little USB memory key. And so I went to the Best Buy, and I got myself a little USB flash drive because we had to have one for whatever the class I was taking. And what kind of space do you think I had on that bad boy? Paid about $35 for it. How much space do you think I had on there? A lot. I had 256 megabytes. 256 megabytes, okay? You guys are savvy enough to know that that's not a lot, okay? $35 today could buy me a terabyte, okay? But back then, in 2002, it bought me 256 megabytes. And it was funny because, you know, they operated in powers of 2 as well. So, like, I don't know if you guys have ever shopped around for that type of thing, right? But, like, let's say nowadays you could probably get gigs, like you get 256 gigs, okay? Those choices are based on powers of 2 as well, because a lot of computer coding deals with what's called binary, and those are powers of 2, not to get the cart before the horse. But, you know, powers of 2 you'll see quite frequently. Anybody ever play some old school Nintendo? You guys know about Nintendo? What's the very first Nintendo system that came out, like that was widely used? The NES, the Nintendo Entertainment System. Classic, okay? That's where you take the cartridge, you blow on the cartridge, you put it in, you push it down, you close the lid, and Lord willing, and creek don't rise, you push play and it goes, okay? That was 8-bit, okay? And then the Super Nintendo came out, and oh mama, it was 16 bits of glory. They had awesome games on the Super Nintendo. And then the thing that blew the doors off, okay, came out in 1998. It was called the Nintendo 64, N64. And they had things like GoldenEye, where you could play multiplayer. And they had like the Ocarina of Time, one of my favorite Zelda games of all time. Anyway, I mean, think about it. What were they based on? They were based on powers of 2. Okay, and actually a gigabyte, we were talking about gigs a minute ago, you might think is 1,000 megabytes. It is not. It's 1,024 megabytes. Again, a power of 2. So interesting little trivia there for you guys. It would be smart, it would behoove you if you guys memorize some of those perfect powers. And then also perfect cubes. I don't know if you guys learned perfect cubes, right? Mossy, what's 5 cubed? Got that one memorized? 5 times 5 times 5? 125, okay. What is Alex, what's 4 cubed? We said this one earlier. It's also a power of 2. 4 times 4 is 16 times 4 is Nintendo 64. 4 cubed is 64. So having these committed to memory just makes life easier for us in math class. You know what I'm saying? You know what I mean, Vern? All right. Let's look at example 3. Now, example 3 is all about plugging and chugging, which we've made use of before. What principle do we call that? When I'm, I feel sick, I need to call in I'm deadgummit. I'm a teacher. Who fills in for me as a teacher? A substitute teacher. And so we use which principle when we're plugging and chugging here? The principle of substitution, right? Now, when we talk about substitution, what should I use to make sure I keep my signs straight? What do y'all think? Parentheses. All right. So what I'll do is I'm gonna go through and I'm gonna scoop out every X that I see, and I'm gonna dump in a 2, and then I'm gonna go through and I'm gonna scoop out every Y that I see, and I'll plug in a -1. Okay. That's easy, right? That's no big deal. But what we want to do is we want to keep straight our order of operations. We want to keep straight our signs and just do a little bit of arithmetic. And again, this is the area that struggling algebra students sometimes stumble upon, is when they're doing arithmetic with positive and negative counting numbers. Okay, so check this out. Let's see if we can do this well. We got 4, and then we got x squared becomes 2 squared. Then we got -2, and then x becomes 2, y becomes -1. We got 3, and then y squared becomes -1 squared. Don't parentheses make it look so nice? You know what I'm saying? Get used to using those parentheses, and you'll keep straight your order of operations. All right, so let's see if we can do a little bit of this in our head. We got 2 squared is 4, 4 times 4 is 16. So that first term becomes 16. You ain't got to do it all in your head, okay? Now, check this out. Look at all that we've got right here in the middle. We've got a -2, a +2, and a -1. So I know a negative times a negative is a positive, and then 2 times 2 times 1 winds up being 4. Okay, and then how about over here on the right side? We got -1 squared is 1. 1 times 3 is 3. So we got 23. All right, and that's just plain Jane. Quentin, can you see all right over this monitor? Are you okay? Raise it up a little bit higher. Okay, go for it. Tiago, question. All right, excellent question. So Tiago says, when you are putting together the 16 and the 4, these first couple of terms, how did you know that the operator was addition? Okay, because earlier it was subtraction, wasn't it? Okay, so there's a couple different ways that we can look at this, and I don't care whichever way you take, but be smart about it. Number one, you could take the original operator, drag it down, and use it along with whatever you get as a result of the substitution, okay? So for example, if I just copied down the negative right there, and then I brought down this other stuff, let me fix my little bracket here. I brought down this other stuff, these 3 things would be what? That would be a -4, okay? And what does minus negative become? If I subtract a negative, that's adding a positive, isn't it? Okay, so you can sort of take the baby steps if you want to right there. You can say, let me drag down the operator, whatever operator it is. Okay, notice I did the same thing over here, didn't I? I'll use blue here. I just dragged down the operator. And then it is what it is as far as the multiplication goes. A lot of times what I will do, though, is if I could go ahead and anticipate, hey, there's going to be a couple negatives, I'll go ahead and swap those out for a positive, as I did initially. There we go. I'll go ahead and swap that out for a positive, and I'll say, hey, look, I saw a couple of negatives in the whole shebang right there. There's a negative, there's a negative. I'll get those bad boys to cancel each other out, and then I'll just multiply whatever it is afterwards. 2 times 2 times 1 being 4. Okay? So whatever floats your boat. I care not. All right? Other questions?
I have a question.
Go for it, Lewis.
So does it not make a difference, like in these types of problems, to just add parentheses to the negative numbers and the positive numbers?
It's absolutely necessary for you to put the parentheses with the negative numbers. So like with the y, I would mandate that you did parentheses with the y. It's not as necessary with the positive numbers when we were evaluating like x equals 2, for example. It wasn't absolutely necessary, but I would still strongly encourage it. I tell guys every time, if you're substituting, I don't care what you're substituting in, use parentheses. Get in that good habit now. Lewis, does that answer what you're asking?
Yes, sir. Thank you.
Awesome. Anybody else? All right. Let me see if you guys can do one on your own. I'll give this one a try. Okay. Real similar setup. I mean, almost identical problems. You guys give this one a try, see how you do, and then we'll get a couple guys maybe to explain their rationale. I tell you what, fellas, I'm getting older and older. My back is killing me still. It's been like 4 days and it's still hurting. Told my wife if I was a vehicle, my check engine light would have been on. All right, Jack McBee, I'm gonna pick on you, son. What'd you get for that first term? Just the first term.
Can you hear me?
Oh yeah.
Okay. I got 75.
Beautiful. We got that by saying 5 squared is 25 times 3, 75. Okay. Drew Benton, what'd you get for the second term? Nice and loud for me. All right, 30. So we had negative 2 times 5 is negative 10 times negative 3 would be 30. And note that that's a positive 30. Again, because a negative times a negative. All right, we had an even number of negatives. All right, Grove, what about this last term? What about the third and final term? What do we got? Grove, can you unmute your mic, buddy? You with me? Hello, Earth to Grove. Rats. Okay. Well, then I guess I'll just ask Paul Camillo. Paul, what'd you get for that third term? Negative 54. All right, well, let's see here. 3 squared is 9 times 6 would be, I think, a positive 54. All right, so let's double check that one, Paul. The reason it would be positive is because what we're squaring is y. Okay, that's what we're squaring. And what y is a negative number. And so if we plugged in, like let's say we had 6 and then negative 3 squared, that negative gets squared with the 3. You know what I'm saying? So that's why that's going to end up being positive 54. Okay? And then we tally all that up together. What'd you guys get? 105, 159?
Yes.
159. Ooh, doggy. All right, very good. So what we want to do is we want to become extra proficient, uber proficient at plugging and chugging accurately with positive and negative counting numbers. Okay? That's the integers. Easy enough. Okay? So when we work through problems like this, it's always smart to use parentheses. Okay? And I want you guys to do a little bit of homework, practice with me here in your textbook, which you guys have downloaded, right? In section 1.2, okay? In section 1.2, we're going to look at numbers 60, and then we're going to go all the way down. My computer catch up. We're going to go all the way down through 126. 60 through 126, but we're going to do what's called multiples of 3. Okay? Now, multiples of 3 means that I do 60, And I skip 61 and 62, and then I do 63. And I skip 64 and 65. How do I tell if something is a multiple of 3? Well, not if it has 3, 6, or 9, because, for example, the yeah, there we go. You're going to add up the digits, okay? So like 72 is a multiple of 3. That's one that we should do here because 7 plus 2 is 9. 9 is a multiple of 3. So when we're working a problem, if we're curious, ooh, should I be doing one? Just add up the digits of it and see if it's a multiple of 3. And if it is, then you should do that problem. But again, this is found in our textbook, and you'll do it on pencil and paper. And what I want you to do is come to me Thursday. Whether you guys that are here in person today, you'll be at home, obviously, and then you guys that are at home, you'll be in person. Come to me Thursday with some questions. Say, hey, can you go over this one? Or can you help me with that one? I will remind you guys that you've got Bob to help you. Have you guys met Bob before? Y'all don't know who Bob is? You guys at home, have y'all met Bob? Lewis, I can't believe you don't know Bob. Bob stands for back of book. What's in the back of the book? The answers for the odd numbered problems, which isn't all of these. Multiples of 3, some of them are even and some of them are odd. But you can check your answers with Bob and see how you're doing on those odd numbered questions. The way that you would access that is you would just go on your little table of contents. It's at the very end, isn't it? Back of book, right? So when you guys are looking through and doing these, feel free to check your answers, make sure you're doing them right, and then bring me some questions, okay? Bring me some preguntas when you get to class on Thursday. And we'll go over a little bit of this, and then I might have a fun little activity for us either Thursday or Friday based on some of this stuff. All right? Y'all got any final questions before I send you on out of here? All right, excellent job today, fellas. Live Jesus in our hearts.
Forever.
All right, and I look forward to seeing y'all again on Thursday. Thank you so much.
Yeah.
The book is on openstacks.org.